Physics is known for being hard or difficult to understand and learn. There are many reasons for this difficulty, ranging from being heavily math-based to its abstract nature. Whatever the reason, students often avoid taking physics until it's required, and even then, they sometimes don't ever learn it. According to a 2016 article for Education Week, 2 in 5 high schools in the U.S. do not offer physics. The article says, quote, "The numbers are worse in some states than others. In both Alaska and Oklahoma, about 70% of high schools don't offer the course. Florida and Utah are close behind, with nearly 60% of high schools lacking physics. Iowa, New Hampshire, and Maine do much better, with only about 15% of schools not offering the subject." End quote. So not only do many students grow up thinking physics is hard or even scary, but in many states, students aren't even taught basic physics and never get exposed to the topic. Both of these issues cause the field of physics to seem inaccessible to the general public, creating a cycle that continues for generations. Many scientists study physics education research, or PER, to try to break this cycle and make physics more understandable. PER is literally how physics is taught and learned. PISEC, which stands for Partnerships for Informal Science Education in the Community, is an educational outreach and research program within JILA that uses PER practices and activities as the basis for its own PER research. From its ongoing projects, PISEC has looked into how learning physics outside of the classroom can be influential in helping students have successful STEM careers.
At its heart, education is the fundamental form of investment in the future of individuals' lives and the future of society more broadly. Full stop. There's no better form of investment of an individual or social infrastructure in our collective futures and individual futures than education. This is why then physics education, of course, is fundamental. There's a quip, of course, if you want to see the past, look to the stars. If you want to see the future, look to our classrooms or educational environments like PISEC. Education can be transformative for both individuals and society alike. And it's not only a way for us to envision, as I just suggested, but to enact the future itself. So it becomes both a vision and a goal of what it is that we do. So at the same time, longstanding people have known this, that education is important. I can talk about why we know that this is important, but we have to engage in this as a scholarly endeavor and a scholarly approach.
That was University of Colorado Boulder physics professor Noah Finkelstein, who is one of the principal investigators of the PER group here at CU and the founder of PISEC. This is part 2 of our podcast episode series on PISEC. If you haven't heard part 1, I recommend going back and listening to it, as we covered the personal stories of those in PISEC, why they joined, how they got involved, and why everyone should participate in something similar during their physics or research career. This episode goes bigger, looking at PISEC in a broader context, how it's contributing to breaking down barriers in science, furthering physics education, and its impact on the larger Colorado community. Just like in the last episode, you'll hear from 6 PISEC members and volunteers: Jessica Hain, Lindsay Anderson, Emma Nelson, Kai Cash, Cameron Harris, and Alex Fix. You'll also hear from 2 new voices, one being Noah Finkelstein, who you just listened to, and the other being graduate student Nicole Silver. While some are studying PER and its impacts, others have seen firsthand how making physics more accessible to all audiences can inspire the next generation of scientists from all backgrounds. You're listening to Humans of JILA, a JILA podcast focusing on the human narrative of the institution's researchers. I'm your host and science communicator, Kenna Hughes Castleberry. Every month, I tell the story of a researcher or group within JILA, showcasing the human sides behind the science. If you enjoyed today's episode, please like it on our YouTube channel or follow us on Spotify, and be sure to share it with your friends and family. This episode features interviews with various PISEC members, from senior undergraduates to the director to the program's founder. So whether you're a physics researcher, a student curious about physics, or you want to learn more about how to make physics more accessible, stay tuned as we explore the work and contributions of PISEC. Let's begin our story. In order to truly understand how much of an impact PISEC has made, it's important to get some historical context. That's why I asked PISEC founder Noah Finkelstein to tell us a bit about how and why PISEC was initially founded in the early 2000s.
Long history, and I will also say I often find in these matters that the end is in the beginning, or the origin stories shape how structures become and evolve. Doesn't necessarily engage predictively in all of this, but the founding of PISEC served the interests of the University of Colorado and JILA and the communities with whom we partner. So it was in about 2007 or so, a few years after I arrived, that was actually my 5th year, that we hired a new education and outreach director for the Physics Frontier Center, one of the national jewels in science in the world as well here. And we conceived of expanding the capacity. That was not the first time that we had an education director, but I do believe Eric Cornell was newly minted as director of the PFC at that time, and he and I partnered on considering what would be expansive roles and innovative roles for the education director of the PFC. And so in that light, we created a partnership between the physics department, or PER group, and JILA, the PFC in particular, to conceive of a more engaged and sustainable and expansive approach to participate in the community, to serve the interests of JILA, to fulfill the charge and mission of the federal funding here. So we imported a model of educational partnership, often referred to as outreach, although I don't use that word. If we want to get into that, we can talk about why. But I happen to have been brought up literally as a child and then ultimately as a scholar in an educational partnership program known as the Fifth Dimension that was founded out of the University of California, San Diego, the Lab of Comparative Human Cognition. This program was started in 1986, more formally. I had participated literally as a child in precursors to this. It is an international program now. It runs throughout all of the University of California system. And the Fifth Dimension is based on sort of 5 principles as articulated in relatively recent write-ups in a book about that. One is to meet the need for enhanced educational achievement, both in terms of content and participation in educational systems, to move outside the formal educational system to partner and support educational engagement and achievement. The second goal is to address the underrepresentation of constituencies in our academic fields, in our society, in positions of privilege and power, and to create a third item here is to create a structure for ongoing interaction that capitalizes on diversity and brings children together with adults of various ages and across demographic groups, socioeconomic status, cultural groups, into a partnership model. The fourth is to create settings where those staff implementing the programs, both from the university and from the community, and the students participating, all stand to benefit from this program. And the fifth is to develop programs that can be incorporated into the ongoing operations of the local community organizations and their university partners to be sustained over time. So those are the 5 principles of the Fifth Dimension project here. I would say that I built on this, and this is actually what I did during my postdoc when I was at UC San Diego before I came here to the University of Colorado, was I created a physics-specific version of this, or a science-specific version of this, and ultimately then a STEM-specific version of this, although back in that day, it was called SMET. That tells you how dated this is. STEM used to be SMET. Same acronym.
Right.
We've added, in addition to the content focus, it used to be about basic forms of literacy, particularly math and language. We expanded to bring into the physics, science, and STEM fields here. We really wanted to reconceive the roles of all of the essential participants. The children, the institutional structures, and even the disciplinary domains are all considered partners of this model. And this was to reconceive the notions of their interaction and what it meant to be in these roles. So, for example, for the children and the UEs, we wanted to really augment the identity and roles that the children would engage in. So you heard in the last episode, to foster their sense as science capable, to be engaged, to feel a sense of belonging, to have a college going mindset and trajectory and where they were at. And the flip side of that I'm so proud of the UEs and the director, Jessica Hain, currently, and previous directors, to really focus on this as equal partnership in terms of impact for the UEs, as the UEs are part of the scientific community themselves and part of the to engage, to communicate, and belong, and to develop the skills towards these ends to complement their so-called bench skills or theoretical skills or graduate and postdoc and undergraduate level studies that they engage in, to the broader swath of what it meant to be or means to be a physicist or scientist more broadly. So that's the first cohort to reconceive of their identities. The second cohort is the institutional structures themselves. What does it mean to be a university? What does it mean to be a community partner? What does it mean to be a K-12 school or after-school program? And the sense is honor the existence of all of these communities here, but move the sense of partnership and engagement to move from outreach, where we deliver models to do good works here, to move from community and service sense to a centralized and core identity of this, which is, what is our core identity at the university? We are about knowledge generation, learning, research, engagement, and service. That is our core here. So we've moved this from the fringes of the institution of outreach to the central identity of teaching, learning, service, and research as what we do. So it's the same part and parcel of what it is that we do. So that part of the PFC identity is PISEC now, and we've been recognized for that. The third is then scale is maybe the largest and most meta scale, which is to actually help reconceive or broaden the definitions of the disciplines themselves that are engaged. What does it mean to do physics?
Right.
What does it mean to learn physics? What is physics itself? Who gets to participate in physics? And to what ends are we engaged in this? So to poke our heads up just a little bit and expand from our incredible historical trajectories of knowledge generation and capacity building among partners, to expand that, to recognize how we talk about physics is as important and part and parcel of the doing of physics itself. In fact, it is part of physics, and who gets to participate is part of physics. So that's sort of the origin stories and some of the goals behind this. I couldn't have asked for better partners throughout the years in all of this. In a nutshell, this is about building a program that focuses on engagement, participation, and sustainability. We do that through collaboration and multi-layered forms of engagement so that the children participating in this have voice in what it is that they participate in and do. The UEs not only help construct the program, benefit from the program there, but get to listen and give voice to the children to participate in all of this. And similarly, of course, the directors have expanded the program well beyond some of its origin stories and challenges, and you'll see this. And of course, the PFC has helped, and directors of the PFC have really helped its trajectory. Our current research project that Dr. Hain and I are involved in right now, along with several other scholars, is the brainchild, no surprise, of Eric Cornell, who said, hey, what's the longitudinal impact of these programs? How do we impact the lives of people participating? I can go on at great length about that, but what a great research question. And thanks to Eric for being tenacious and never letting go of that research question, which we are now taking on.
While Noah spoke about more of the abstract ideas on physics education, the rest of the PISEC members have a slightly different viewpoint. Unsurprisingly, when you ask people who teach physics why physics education is important, you get many personal and anecdotal answers. That doesn't mean that these answers are invalid or only relate to one individual, but it shows personal connections and personal passion for learning in physics.
It's really just important because I'm mainly working from anecdotal experience here, but it doesn't seem like there are many strong opportunities for people to have physics education before they come to college. Personally speaking, I never really had much of a strong science lab at all in any of the schools I went to. We didn't really have great equipment or curricula. And the only time I really had a formal physics curriculum that wasn't my own studies was just one class in high school. And for a lot of people, the tricky thing about physics, one of the big barriers I feel like, is this idea that you have to be super academic, probably a little stuffy, very strong at math in order to even get started.
Right.
And then when your first experience is probably just your college freshman physics 101, where you're being thrown all of these fundamental concepts with a lot of equations to back them up, and that's just reinforcing that.
Yeah.
So if you have the opportunity to get into physics earlier, you can see, okay, yes, it's true that I need to have strong study habits. I need to know a lot of math, but that's something I can learn. If you come in with that interest beforehand, then it's not as daunting because you're like, okay, yes, there's a lot of work to be done here, but this isn't something I was already expected to know, some specific mindset I was expected to have. And another issue for a lot of students is just that, in the popular media, or really just the stereotype, is that there's only one type of person who becomes a physicist, less social, nerdy person, probably a white man. So with PISEC, we go into a lot of schools that have more diverse populations, and a lot of our volunteers have more demographic diversity as well. So it's really important both for the students to be able to see themselves as a scientist and also see different types of people who are scientists working with them, so they don't just come into physics and go, oh, well, that's not for me anyways. I don't fit the demographic. I'm not already good at math. I don't already know all these equations, and just give up before they can get started.
That was Alex Fix, a senior undergraduate at the University of Colorado Boulder who volunteers with PISEC. As a quick reminder, you can listen to Alex's story, along with the stories of our other interviewees, back in episode 1. Like Alex, graduate student Kai Cash, who uses they-them pronouns, also believes that physics education deals with the field's history of having a similar demographic in its main figures and role models.
I think that, especially historically, physics as a community has a sort of PR problem. Scientists, especially physicists, not very good at communicating necessarily what they are doing in a way that is understandable or accessible to the general population. And I think that this happens all over the place. I mean, it happens with publications. It happens with talking to physicists sometimes. And I think it happens a lot in the physics classroom. So part of kind of my motivation for studying physics education is going, okay, but it doesn't need to be inaccessible. I mean, we've got an entire world, we've got a whole community of people, and there is no reason necessarily that I should be doing physics over somebody else. We should all have the same opportunity to do physics and to learn about the world. That doesn't need to be a thing that's restricted to just a specific class of people. I think in order to figure out how to improve that, I think you kind of need to do research into what we have, what's working, what's not working,
right,
and take that research and use it to improve upon it the way that a physicist would take research and use it to improve upon their own experiments. But we need to do that with our own education.
Graduate student Nicole Silver, who is in the School of Education, gives a more big picture view on the importance of physics education.
Hi, my name's Nicole Silver. I'm a second-year grad student in chemistry as well as the School of Education. Yeah, so in the School of Education, we focus mainly on equity, and we're trying to move from a place of memorizing facts and doing problem sets to student-driven learning, which is a lot of times phenomena-based.
Okay.
So they're able to observe something, and then the students get to figure out what's happening, and they drive the instruction rather than you presenting them with facts and then doing a lab that supports the facts that you just said. So I think it's really important that students are able to come up with their own ideas and they can use their critical thinking skills in the future rather than these memorization of facts that aren't super useful in problem solving. And then another thing that's really important, especially in physics, but also chemistry and a little less bio, is there's a huge gender inequity. And a lot of times at a young age, you don't see yourself as a science person. And this deters you from trying to do science classes or science experiments. I think PISEC, since it is young children, it gives them the opportunity to be like, yes, I am a science person. And then hopefully that allows them to want to do a career in STEM.
For PISEC members Lindsay Anderson and Emma Nelson, the personal experience of trying to explain their technical research or observing the progress of the students developing their own science identity makes them see firsthand the importance of making physics more accessible. Here's Emma.
Yeah, I feel like, so even as an adult, explaining my research and telling other adults what I do, people are always like, oh my gosh, physics is so hard. Yeah. And I feel like that idea starts really young because I didn't take any physics classes until like the end of high school. Right. And so I think that, so I saw, and I think a lot of people don't take any physics classes at all or don't take it until they're older. People can see physics as really intimidating. And I think part of that is just because they don't start thinking about it until they're older and maybe already have decided they don't want to do anything math or STEM related. And so I think it's really important to get physics education started when you're younger and are more open to kind of these ideas so that you can not see it as something that's scary and too much math and actually see it as like a really exciting topic and an approachable field too that anyone can do. And so, yeah, I think that's one of the cool things that this form of informal physics education is doing is it's showing kids that physics can be really cool in a way that's fun and not actually hard and intimidating and unapproachable.
Lindsay looks at this idea in an even broader context.
I'd like to maybe beyond just physics education, like physical sciences education as a whole is so important because a lot of people don't think that they can do it. They'll immediately be like, oh, I can't do that. Oh, it's too hard. And these after-school activities where the students get to learn by play, that's like the whole PISEC mantra, I think really allows them to recognize themselves as scientists and recognize themselves as physical scientists. So then they won't be as nervous to sign up for physics or chemistry because a lot of those aren't required to graduate. I think especially physics isn't like required to graduate from high school. And so I think that having these experiences when they're in middle school or earlier can really help set them up to see themselves as physical scientists or recognize that's like a possibility for them so they'd at least give it a try.
I then asked Jessica Hain, the director of PISEC and the director of Public Engagement and Education Research within the JILA Physics Frontier Center, an NSF-funded center that supports PISEC, her take on this. Jessica has a background in PER, so she's very familiar with the importance of studying physics, education, and making physics more accessible.
So why is physics education important? I think just maybe the question that kind of goes to the question of why is physics important? You know, it's important to understand the physical phenomena around us that govern our world. And so, of course, physics education is important for creating and training physicists. I think everyone should have the opportunity to learn physics if they're interested in it. People might not know they're interested in it until they've been exposed to physics. So that's a huge part of physics education in general. Just making sure people have the opportunity to experience the excitement of figuring out how the world works around you. And that can be really empowering. Historically, our field, much like other science disciplines, has not been very inclusive or welcoming of different types of people. So that's a big thing that in PER specifically, you know, we're working to change. We study various aspects of physics education in various environments and work to improve those physics education environments, in part to change that and kind of change the climate and the culture of the field.
By now, you've heard similar ideas in many of these answers, and quite a few of them touched on this issue of role models and breaking down stereotypes. To dive into this further, I followed up my previous question with one about how making physics more accessible, more understandable, and less scary could help break down these stereotypes.
In an ideal situation, the class that you are teaching not only conveys the physics concepts that you are trying to teach, but also fosters this, like, you can do it. Anybody can do it. It doesn't need to just be like people who think about this a specific way or come in with this background already predisposing them to this concept, this content, right? Like, anybody can do this. And once you kind of, the goal, hopefully, of, you know, reforming these classes is to make it more accessible to everyone, not just those, that specific subset.
While Kai's answer focused on more of the classroom setting, Jessica instead moved towards the idea of science identity.
And so you mentioned there's lots of stereotypes and barriers in terms of who do we see as being physicists. Historically have been white males. That's changing, but it could change faster. And so in PER, we do lots of different things in terms of working in classroom environments from K-12 through university, even graduate level, to try and help improve physics education. In PISEC specifically, so kind of bringing it back to PISEC and challenging those stereotypes in terms of who can be a scientist. In PISEC, what we're all about is that the youth are the scientists. So we're really there to help them develop a sense of identity as a scientist. And so what that means is it's really open-ended, and they get to ask their own questions and figure out how to answer them and design their own experiments, all with the guide of a CU scientist, but really working with them at a young, impressionable age. I think we can do a lot to help them develop a sense of themselves as someone who could be a scientist or who is a scientist, and really empowering them in that way. So that's one way that we can sort of start to break down those barriers and challenge those stereotypes, provide opportunities for youth to be the scientists.
Noah approached this topic from an even more infrastructure-focused perspective.
How does this break down barriers? I would say we are building on the scholarship of how people learn and how institutions organize and change. So there are some key principles within this. One, we meet learners where they're at. For the history of our educational system, and particularly higher education, we have expected students to match our institutional structures. And in fact, our institutional structures were created for a relatively different demographic of student than who is now showing up, both within our school system and within higher education itself. So maybe it's time for our institutions to meet learners where they're at, or at least halfway, and we can adapt. The second sort of theme that I would say is this gives us research-based models on how to engage and in partner, community, and people-centric educational practices. This gives us models for how to create successful programs. We directly conduct studies on the nature of belonging, inclusion, access, and equity in our programs, distinguishing among those, I might add, but then enacting those and building those into programmatic activities, not only within PISEC, but within our undergraduate education, across our K-12 systems, even in our graduate educational programs here that we're involved in. Ultimately, this field has actually started to identify the structural and systemic biases that limit and prevent who can come in, and affordances, the selection effects for whom it draws and creates. So it can point out to us that we have a strong cultural system, for better and worse, in our system. And then finally, it gives us research and scholarly based models about how to change. It's only in the last really 2 decades that we've started to focus on how do institutions themselves learn and adapt. We have demonstrated that we could triple the amount of students learning in our introductory physics class back in 2005. We have a great paper on all of that in our large-scale introductory physics class. But then the question is, why does the next professor come in and teach however they want? What are the institutional structures? And we were as naive about how institutions adapt as we were about learning. Our model of learning used to be, we tell people they learn, they absorb, they're empty vessels. That's not true. It's never been true. People learn by engaging, by participating, by being active. Learning is a matter of socialization and engagement, what I actually refer to as enculturation. It's bringing people into communities. And the same thing is true with institutions, that institutions, the models that we've had about how institutions change used to be, hey, I wrote a paper, why don't you go do it? And what a great academic model that doesn't work. And so now we're writing new papers about the new models that actually do work.
The idea of breaking down stereotypes around science is beneficial for many future scientists, but can be especially helpful for those from underrepresented backgrounds, as they can find new role models and feel a stronger sense of belonging. To this end, I also asked each of our interviewees how PISEC impacts the JILA community and the wider Colorado community.
Yes, great question. So I don't know if I already mentioned this, but since PISEC began over 15 years ago, we've been doing research on the program. So we're continually conducting education research on the program in order to, one, document the impacts of the program, and then 2, to advance knowledge in the field of informal physics education. And so we have many impacts documented of the program. In terms of our volunteers, science communication skills are a big part of it. So UEs report a development of science communication skills, feeling more confident explaining complex concepts to a non-science audience or a younger audience. Volunteers also report a sense of belonging to a community. So PISEC is really fun. We have social events. You get to meet other students, not only in physics, not only within JILA, but from a variety of departments around campus. And so that's a really cool way to build community that you wouldn't really otherwise build. And a sense of community can be really important for undergraduate students, graduate students, postdocs, anyone, persistence through a STEM degree or a STEM career. And so that's really important to me that is an impact that PISEC is having on the JILA community and more broadly the CU community. They also gain teaching experience, leadership experience. So PISEC now employs, this semester we have 6 site leaders who are paid to run an individual PISEC site. And so for our leadership team, they're developing lots of really good leadership skills, which I think is a big impact. In terms of the JILA and the Physics Frontier Center more generally, PISEC helps bring awareness to JILA, to our research, to the PFC, kind of out in the broader community, folks that might not otherwise ever hear the name JILA or hear it and not know what that is. And so one way that we do that is at the end of the semester for the primary kids, we bring them here for a field trip. And so we do lab tours and liquid nitrogen demos and all sorts of fun stuff. And then for the high schoolers, they come to JILA every spring for a poster symposium. That's right. It's happening on April 24th. Hope everyone is there.
If you're listening, put it in the calendar.
Yeah, mark it on your calendar, 10 a.m., April 24th. And so that's another way that, students get to come here and see JILA and see our labs and learn what we do and kind of what opportunities are here and kind of on campus more broadly. So that's, I think, benefits to JILA, the JILA community specifically. I guess I will also say a little more general. It's really important for JILA and for CU to have strong connections to our kind of surrounding communities. So K-12 communities, community organizations, we learn a lot from them, just like they learn a lot from us. And so I think that's another benefit. Let's see. In terms of, so you asked about impacts also on the Colorado community. So we do have lots of documented benefits for our youth participants, obviously who the program is designed for. And so we see that they develop an interest and excitement for science. They develop a science identity, which of course is one of our goals. We want them to be able to see themselves as a science person. Sense of belonging is huge. So do I fit in science or in STEM? And then, as I was just mentioning, awareness of opportunities in STEM. Some students, their parents have never gone to college or they don't know any scientists. And so PISEC can kind of help develop that awareness. And then, of course, they learn physics, which is great. They learn lots of cool physics and really building relationships with CU scientists. Just to share one quick anecdote, I was interviewing current high school students who participated in PISEC when they were in elementary and middle school when they were in elementary and middle school. And one of the things I was asking them, how did PISEC impact you? What do you remember? And one of the things that they remembered was the CU volunteers that they worked with. They even remembered the names of the people that they worked with. And this was, 7 years later, they're now a junior in high school. They're like, yeah, that was really impactful for me. I loved hanging out with these people once a week. So that is really awesome. And can certainly be really impactful. More generally, in terms of the communities that we work in, PISEC helps provide a fun, safe place for youth to go after school, which is huge for our communities. In particular, the schools we work with, the organizations we work with are always looking for fun STEM-related opportunities for their youth. And so that's kind of a need we fill, and not only for the youth, but for the broader communities. So last year, we started at one of our sites at the I Have a Dream Foundation, we started a parent night where the parents got to come and their children shared with them their experiments. And so the kids were the experts and they showed them how to do all the experiments and they kind of displayed them for their parents. And so in that way, we're bringing science not only to the kids, but to their families as well.
Right.
Similarly, we hosted a a poster display at the Lafayette Public Library last summer, and the kids' posters hung all summer, and we had like interactive thing with the community. So in that way, we're impacting not only the youth who are participating in the program, but their families and their kind of surrounding communities.
For Kai, leading the newer I Have a Dream Foundation site has given them similar insights as Jessica.
So most of these places we're going to sites where there are students who maybe are traditionally underrepresented in science and in STEM, especially like in high school and in college and even decidedly at the PhD level, right? And their schools, some of them are kind of STEM-oriented schools, but for example, the group that I work with is a foundation that, at least the one that I'm a part of, is based at a housing site. And it's just elementary school students whose parents live in this kind of lower income housing site area. So it's students who like wouldn't have access to that sort of resource necessarily without this program, giving those students the opportunities that they need to, see themselves as scientists and maybe consider a future in science.
Nicole, like Kai, answered my question looking more at the demographics of the communities PISEC interacts with.
I think Colorado is very segregated, I'd say, just based on location. Like in Boulder, as you know, there are a lot of white people, but the schools themselves have a lot of like Latinx and Hispanic students. So I think it's a good way to bring everyone together and also give students a lot of choice, because a lot of education is a lot of like teacher driven, and this gives student driven opportunities.
Moving away from the demographics, others like Cameron see PISEC impacting JILA and the CU Boulder communities in a more immediate way than PISEC's partner sites, as the UEs or PISEC volunteers learn valuable skills.
So here at JILA and in CU, it's a great way to bring people together. Like I said, I got to meet a lot of people throughout my experience here, and programs that I wouldn't have interacted with at all if I hadn't been working with them through PISEC. So being able to connect with other people, a lot of the people I knew from classes but didn't get to know very well, and it was a great opportunity to meet them. And also as an undergrad, I'm always looking for advice for grad school and what to look for and what I should be doing. And being able to work with PhDs, it's been awesome. They've been giving me invaluable advice, and I still stay in contact with a few of them who have since moved on and gone to other places and stuff. I still email them every once in a while with questions. So it was a great way to get involved. So as far as a community, it's really good for the community building. And then for, of course, working with students for the outside of CU, it's a great way to get involved and see kind of how physics and things are being taught nowadays in schools and how children are interacting with it. And I think it's a great way, like, for all these students to come in and be able to work together. And there's no strict way that they should be doing it. They're there to learn. So there's some brief instructions, but they really just kind of do what they need to do and what they want to do. And for them to be able to pose questions, it has me rethinking some things. And especially going through some of my undergrad physics classes, going back to some of these experiments and looking at it like, oh, that's how that works. Right. Or seeing it in an informal setting not only helped me learn myself, but be able to better teach them or be able to share experiences with them.
Emma also agrees that PISEC helps connect the university settings to the local communities, allowing opportunities to share the wealth of knowledge.
Yeah. So, I mean, kind of as I was saying, it's an opportunity for JILANs to, like, give back to the community and just be involved. And I feel like it helps forge connections between the University of Colorado and these kids in these schools. Like, for example, at the end of each semester with these PISEC programs, the kids actually get to come to CU where they get to see labs and meet professors and do cool activities. And it's just these kind of connections are both beneficial, I think, to the kids who are doing it, but also to the JILANs who get to see, like, get to help out. And yeah, these connections wouldn't be possible, I don't think, without programs like PISEC.
Alex echoed Emma's statements by saying,
really, I think the biggest things for the JILA community, I mean, there's the just personal impacts of, which I can talk a bit more about later, of just how it helps with your teaching and your social skills and just giving you a break in your day. But also I feel like it's just a good way to bring the community together. I feel like when I worked at JILA, I was mainly just working in the tower. So I really only knew the people who were in my research group, or I would see people occasionally at some of the snack events or colloquia. But since doing PISEC, I've met a lot of people who work in and around JILA, and now anytime I'm in the hallways, I see at least one person who I know, and we can have a quick conversation that really makes the whole building feel more personal and human. That, okay, I know this person, they're not just closed behind their lab doors all day. And for the broader Colorado community, I really think, we're going into schools that are we have a site here in Boulder where we work with the I Have a Dream Foundation. We also go into schools in Longmont and other nearby cities. So we're being able to show that we're not just here doing our research detached from everybody. We're giving back to the local schools. We're able to inspire some of these students to come to Boulder, and if not, at least just continue a scientific tradition in the future. And I feel like it's just an important way for us to, for us to just kind of immerse ourselves in the community, rather than it being, there's the university, there's the people who are part of the community outside of it, but rather this is a whole part of the city and what makes us what we are.
Noah gave me even more concrete examples of the direct sharing of this wealth of knowledge between PISEC and the Colorado communities.
Well, one of the things is we actually document and measure this. We have studies that look not only at how the learners are developing in the system, the children participating, the UEs participating within that. So that's a core study. We've also simultaneously been looking at how do the host institutions adapt to engage and participate in all of this. But in short, this is an amazing partnership here. And I would say at least a three-legged stool, which is strongly linking the physics department and PER group with JILA and the PFC, and working with and benefiting students, both the UEs and the community-based children, and the host institutional partners within that. So I love that the JILA's Physics Frontier Center has been heralded by the National Science Foundation as a leader among the PFCs, including recognition for its educational work. Both the notion that it has been recognized for conducting research on education and outreach in this, not simply, and drawing models from scholarship and providing models for others to use. I love the ingenuity and development of each of the JILA PFC educational community engagement and research directors. That title has changed over the years, but currently you've just heard from Dr. Jessica Hain, and who's built incredibly on this, but previously Dr. Mike Bennett, Dr. Claudia Fracciola, Dr. Katie Hinko, Dr. Laurel Mayhew, each has built and expanded our working capacities in innovative ways. This started as a late elementary, early middle school program. It's expanded into a high school program. I think that was Mike Bennett who ended up building into this, which is just fabulous. I love that we've built in a field trip program, not only going, think about how powerful it is to go into literally where you live when we partner with housing centers, going into where you live, meeting you literally where you're at as a child, and bringing the science to you to recognize that it's relevant to you and your everyday life. That's the model of PISEC as it adopting from the fifth dimension precursor for all of this. And we expanded on that and said, all right, we've learned about your worlds and your life and brought that to you. Now we'll bring you back up to the university so you can start seeing what it means to participate here at the university. Not only seeing the same electric circuits that you built with snap circuits there, and see the slightly fancier versions that exist within the JILA labs that are going on here, but also then literally to take over the JILA auditorium, the home of prestigious presentations from Nobel laureates and MacArthur Award winners alike, and the children get to take over, own, and present in that very same space and medium. They get to see themselves participating in that way. The expansion to the high school program, as I alluded to before, that we host a high school poster session here and science fair with hundreds of youth, historically not represented in the physics field here, not necessarily seeing themselves as science identified or college going necessarily, or certainly to one of the most prestigious institutions of higher education when it comes to physics. They get to come here and participate as a peer, to participate in an authentic scientific activity, a poster session, which is what we do in our conferences here. I would say that this serves as a model of engagement, of partnership, and I'm very pleased to see that this is expanded and been shared with others throughout the state of Colorado, but also nationally, that we engage in and we partner with other institutions and conducting studies as well as sharing models. And even internationally, many of our efforts have influenced the work that is going on internationally here. In fact, we have a great partnership with folks who run a program called Quavers to Quadratics, which is a partnership between the University College Dublin, UCD, and the National Symphony Orchestra of Ireland, along with the schools. And they partner here. It's a fabulous model that we have fostered the development of and learned a great deal from our colleagues there.
While PISEC is growing by adding new external sites, the program itself is starting to expand within CU Boulder. I'll let Lindsay explain.
We're interested in starting a chemistry curriculum too, and having that be part of the rotation of sites.
Yeah.
And so I think that'll be really exciting.
As both Kai and Lindsay told me in our interviews, PISEC has begun to gain more and more popularity within the chemistry department, to the point where it may create a new chemistry-focused outreach program working in tandem with the current physics education program. Should this happen, this would offer a significant number of opportunities for new volunteers, and most importantly, new partnerships. Being the founder of PISEC, Noah also provided some interesting thoughts on the program's expansion into other fields.
I'm thrilled with the possible expansion of this into chemistry, and whether we start with another room or activity suite that is within PISEC, or we grow into another parallel PISEC program, may that be the case, that we do that in physics, chemistry, engineering, biology, around and about. I think that there's ample room for doing this. I think that more youth would benefit, more undergraduates, graduates, and postdocs would benefit, more fields would benefit from the participation of this, and we have a really nice model for expansion and engagement in this. That's one of the points that I had alluded to before when I had mentioned the possible futures expansion of this and its expansion into different domains, and the fact that we provide a model of interaction. And I think that there is economy of scale. The more this grows, the more we can address the multiple interests, opportunities, and challenges that face higher education and the pre-college environments alike. In this way, are community-based. So I'm thrilled with the expansion of this. Of course, we want to be attentive to this. A great way to kill an organism is to make it grow too quickly. This is from my biology colleagues here. And so we want to make sure that we grow intentionally in all of this. But I think that it's exciting. And we've already done this in some regards. We've had great partnerships with the Fisk Planetarium and developing curricula with them. We have partnerships also with our colleagues at Cal State San Marcos, who focus on this more as an engineering program and curriculum, where they build mobile maker spaces is what they build it as when they go out to engage in community-based activities. So I think that there are ample opportunities for all of this. And I would say the science itself is both an object. We want folks to develop science mindset and science identity and sense of belonging within the scientific disciplines, physics, engineering, biology, chemistry, math. But it is also a medium by which we are socializing people into the future of our society. And so to that end, the more media or domains, again, when I said let's reach learners where they're at and people where they're at, one would be is to say, let's play to their interests. Not everybody should be a physicist, although we can use more, and especially more folks from diverse and underrepresented populations in the fields. But everybody should think of themselves as physics capable, and chemistry, engineering, and for that matter, history, literature, philosophy capable in that way. I think that there are tremendous opportunities for us to expand this model across different domains.
Through this episode, along with the past episode, you've heard about the impacts PISEC has had, not only on the local Colorado community, but on its volunteers, and hopefully even those of you who are listening right now. As we mentioned in the first episode, if you're interested in volunteering with PISEC or partnering with them, you can connect via their website, which we'll have in the show notes. You can also email Jessica Hain. If you're still considering working with PISEC, I recommend you visit their website anyway and see the current sites they're partnering with. Thank you for listening to Humans of JILA, a JILA podcast. Be sure to subscribe to JILA's YouTube channel for more information and to keep listening to these episodes. This episode featured PISEC Director Jessica Hain, founder and CU Boulder Physics Professor Noah Finkelstein, along with members Lindsay Anderson, Emma Nelson, Kai Cash, Cameron Harris, Nicole Silver, and Alex Fix. Production design, sound design, and research by Kenna Hughes Castleberry, with assistance from JILA's Science Communication Office and PISEC. Sounds and music by Pixabay and Kevin MacLeod. JILA is a joint institute between NIST and the University of Colorado Boulder. JILA hosts this podcast. Any use of this podcast without JILA's permission or credit is prohibited.